So to answer this one, as always, we should start by drawing a diagram. So we've got an electric field which looks like this, and traveling in the opposite direction to the field, we've got this proton here, which is traveling at some initial speed u, and we're told what u is. U is equal to 500 meters per second, and we want to work out what the electric field is. Okay, now in order to do that, we'll need to consider the force acting upon this proton here, because it's that force acting in the opposite direction to its motion, which is going to bring it to a stop. So we know that the force is given by the electric field times the charge on the proton, and as this is the only force which is acting upon it, this is equal to the mass times the acceleration. So we can rearrange this and see that the acceleration is equal to EQ on m. Now, what we're told is the time it takes for this proton to come to a stop. So when it's stopped, it's got a final velocity of 0, and it takes 3 microseconds, so 3 times 10 to the minus 6 seconds to come to this point. So the acceleration is constant as the electric field's constant. We're told that, and Q's constant and M's constant, so the acceleration's constant. And so we can use our kinematic equation, V equals U plus AT, where A is given up here. So let's rearrange this, and we can write T is equal to V minus U on A, and we've got A, so let's substitute that in. So we've got mv minus u divided by EQ, just replacing the A with this expression here. So we can now rearrange this because the question has asked us to find E, and we know what T is. So we can write this as E is equal to mv minus u over TQ, and then we can just substitute everything in. So in this question, we were told that it was a proton. So from our data sheet, we know that the mass of a proton is 1.673 times 10 to the minus 27. B is 0. The initial speed is 500. And then we're dividing by T, which is 3.0 times 10 to the minus 6. And Q, the charge on the proton is the same as the charge on an electron, 1.602 times 10 to the minus 19. So then we can solve that, and we get minus 1.74 newtons per coulomb. Now the negative sign here is because the initial speed is in the opposite direction to the electric field. So we're just asked to find the magnitude of the electric field. So in this question, the time was only given to 2 significant figures. So we should write this as E, the magnitude of the electric field, is 1.7 newtons per coulomb. So that's how we solve this one.